Here are the 3 types of gel electrophoresis that you need to know for the MCAT. So this is definitely a high yield concept, and I think I got a question on gel electrophoresis almost every MCAT I took. And the key to getting these questions right is understanding how different proteins will show up as different bands on the gel. For this problem, I want you to consider this protein. It is a dimer consisting of 2 subunits, one that is 100 kilodaltons and another that is 200 kilodaltons in weight. This makes the total weight of the protein 300 kilodaltons. So the first type of gel electrophoresis that you have to know how to apply is native page. So native page runs the protein in exactly what it sounds like, its native state. Therefore, this protein will show up as 300 kilodaltons, as a band indicative of 300 kilodaltons on the gel. Now the next kind of gel electrophoresis you have to know is SDS page under reducing conditions. So reducing conditions means that this protein will be reduced, meaning that disulfide bonds will be broken in the protein. So let's say this dimer, in this case, isn't just held together by hydrogen bonding, for example, it's actually held by disulfide bonds. So if this protein is held by disulfide bonds, and we run it on SDS page under reducing conditions, the disulfide bonds will be broken. And these subunits will separate and run as 2 separate bands on the gel. So in this scenario, we will see a band at 100 kilodaltons and a band at 200 kilodaltons. So therefore, we know that this protein is connected via a disulfide bond. Now the last kind of gel electrophoresis you have to know is SDS page without reducing conditions, or under non-reducing conditions. This means that the protein, let's say, it consists of, let's say it's held together by hydrogen bonding, like in the first scenario. So there's only hydrogen bonds that are linking these 2 subunits together. So SDS page, or sodium disulfate, is a chemical denaturant that will separate the proteins. But it will only do so if they're not covalently connected via a disulfide bond. So if this protein was connected via hydrogen bonding, like in this scenario, it would migrate as a 100 band and a 200 band. However, if the protein was connected via disulfide bonds, they would not be reduced because the conditions are non-reducing. Therefore, this protein will show up as a full dimer at 300 kilodaltons. So the key here is understanding that in native page, the band on the gel will always represent the protein's total molecular weight. In SDS page with reducing conditions, the protein will always be broken apart into its multiple subunits and migrate as separate bands. In an SDS page without reducing conditions, the protein will only be broken apart into its subunits if they are not connected via disulfide bonds. Remember to save this for your next practice test and follow for more.